Hello class, this is just more examples to help you through understanding series. So let's get straight into it. You can pause the video at any time and give these questions a go. So I'm going to move this down. So here we go. In an arithmetic series, the third term is 8 and the 20th term is 59. This one's actually a lot simpler, but here we go. The third term is 8. So the moment you see that a term is going to be used, you should immediately remember that the term for the any term in an arithmetic series is given with the following expression. So the third term, so it's T3, is equal to A plus D 3 minus 1. So the third term is 8. Okay, so simplifying this, we get A plus 2D is equal to 8. The 20th term is 59. So T of 20 is A plus D. 20 minus 1 is 19, is equal to 59. So we get A plus 19D is equal to 59. We can now find A and D using simultaneous equations. I'm going to take A plus 19D equals 59. And the one below, A plus 2D equals 8. Solving by elimination, I'm going to subtract the first from the second. We get A's cancel. 19 take away 2 is 17D. 59 take away 8 is 51. D is equal to, I believe that's going to be 3. 51 divided 17. Common difference of 3. Well, since we have a common difference, we can find A, well, using this formula here. A plus 2 times the common difference of 3 is equal to 8. That's 6, so A equals 8 take away 6 is 2. So we now have an expression for the nth term. So T of n is equal to 2 plus D is now 3, n minus 1. I'm just reading from here and substituting both into the Tn formula. So now we want the 50th term. Is that what we wanted? Yep, the 50th term. That's nice and simple. 2 plus 3, 50, take away 1. That's 2 plus 3 times 49. Oops, that should be a 3. There we go, it's 149. So the 50th term is 149. You can go ahead and pause the video and give this a go yourself. Here we go. I hope you can see just by looking at this is a geometric progression. So let's figure out now. We need the first term. That's going to be 3 over 4. And the common ratio we can find out. Well, since we know it's a geometric sequence, I'm just going to take 6 divide 3. It's a lot easier. It's going to be 2. So Tn is equal to 3 over 4 times 2 to the power of n minus 1. The question now becomes, how many terms are less than 400? Well, to find less than 400, we want T of n less than 400. So which term is the first one to be less than 400. Substituting our equation, 3 over 4, 2 to the power of n minus 1 is less than 400. Well, doing some index laws here. First we'll do 3 over 4. So we'll times 4 divide 3. 2 to the power of n minus 1 is less than times 4 divide 3, because it's the denominator of 4, numerator of 3, so 400 times 4 divide 3. This one I'm going to leave as a fraction. That's 1600 over 3. We could do some index laws here because, we'll do some log laws. We get ln 2 n minus 1, but that becomes the coefficient, so this becomes n minus 1 is less than ln of 1600 over 3 dividing by ln of 2, so n minus 1 less than ln. You know what? I'm just going to take a duplicate here. Dividing all by ln2, adding 1, so n is less than all of this plus 1. Into our calculator, being very careful here, 1600 all over ln2 plus 1. This is 10 point, so n is less than 10.05, etc. Well, you can clearly see that the first term that is less than 400 is the 10th term, so it's 10 terms is our answer. Okay, so let's move on to the next question. What term is the first to exceed 1000? Well, this is question A, or part 1, sorry. Part 2, it says, what is the first term to exceed 1000? Well, we want the t of n to be greater than 1000. Well, we have an expression for t of n. It's here. So substituting that in, 3 over 4, 2 to the power of n minus 1 is greater than 1000. Once again, just going through the exact same idea here. So times 4 divide 3, we get 2 to the power of n minus 1 is greater than 1000 times 4 divide 3. That's 4000 divide 3. Taking ln of both sides, we get n minus 1 ln 2 ln 4000 over 3 n minus 1 greater than divided by ln2 plus 1. Just duplicate this, plus 1 to eliminate that negative 1. Into our calculator, here we go, ln plus 1. It's going to be 11.3, so n is greater than 11.38. So once again, when it comes to series, we can't have the 11.3 term. So the next term that's bigger than this is n equals the 12. So the 12th term is the first one to be bigger than 1000. You can test this because if you put in t of 11, we get 3 over 4, 2 to the power of 11 take away 1. If you substitute that, you'll get a number less than 1,000. But if you put in t of 12, 2 to the power of 12 minus 1, you'll find that this one here will be bigger than 1,000. So I hope that gave you an insight into, well, more of an insight into applying what we know about series, arithmetic, and geometric to different kinds of question. Hope to see you in the next video. Best of luck.